This is Jay Rastegar from OMNITEK'S Partners. I will be talking about our project. This project, its objective is to develop a technology that can be used to increase the runtime of thermal batteries. OMNITEK'S Partner was established in 2000, and we have been, we are located in, to start with, we are located in Long Island, New York, in Ronkonkoma. We have been, since the beginning, been involved in developing technology for both military and commercial market. And in the military side, we have developed numerous types of components and devices and systems for munitions and for weapon platforms. And all these technologies that we have developed have given us issuance of over 230 patents, US patents, and over 100 of them are still pending. And we have close to 15 employees, and we almost all technical, and we have manufacturing and quality control and production facilities, and we also do extensive prototyping, and for which we have full manufacturing CNC machines and electronics equipment, and for manufacturing and testing. And we even build our own testing equipment for testing a lot of the components like shock loading and so on that are not available in the market. We are located, we are inside a 11,000 square feet space, and we have all kinds of facilities, including explosive license for manufacturing components like our inertial igniters that we develop, and we have developed, and we today we manufacture. And we manufacture these inertial igniters that are used for initiation of thermal batteries and for liquid reserve batteries, and also for initiation trains in munitions. And we are really the main supplier of devices, and they work for all gun-fired mortars and rockets, and they provide very, very high safety, and also they can satisfy almost any no-fire and all-fire conditions, and their reliability has been proven to be 99.9% and with 95% confidence level. Thermal batteries are used in almost all gun-fired munitions, mortars. They're used also in bombs, rockets, and missiles. They are really the primary source of power in the munitions. The main reason people use them is because their shelf life is many, many years, sometimes over 40 years, and they are totally inactive in storage before being activated. They are made with electrolytes that are solid, and therefore they don't provide, before activation, they don't provide any power. And they're activated by initiating the provided pyrotechnic materials inside the battery core, and by igniting those, the electrolyte of the battery is melted, and therefore the battery becomes active. Thermal batteries, when they're active, they become active at around 600, 650 degrees C, and therefore they cool, especially if they're small, they cool really fast. And those that are used in munitions, let's say something around half an inch or 1 inch diameter and a couple of inches long battery, they would last only, they stay warm, usually around, they have to stay above 350, 360 degrees C in order to be active, in order for the electrolyte not to become solid. So for that reason, that size battery would only provide power for 40 to 100 seconds. Now the objective here of this project is to increase this runtime by several 100%. In this case, at least 200 or 300%. And that's what we have achieved as part of this project. Now the batteries that you see on the below the picture, this battery there are two batteries there. The one on the left is a regular battery without our technology. The one on the right has a heating fuse element, which I'll describe later, which is used to increase the runtime of the battery. The way it works is that we replace portion of the always provided insulation inside the battery by a heating fuse, which is a tube of pyrotechnic, very slow burning pyrotechnic filled tube, which is compacted and then wrapped around the battery core and is initiated as the battery is initiated. So what happens is that it burns very slowly, and usually these heating fuses are designed to burn at a rate of 10 to 20 seconds per inch, and therefore for a relatively long time they keep the battery core hot, and that causes the results in the battery be active, and which is the runtime is increased significantly. And these two batteries that you see are actual size batteries that are fielded batteries, and by replacing the part of the insulation, we have increased its runtime by 200 or 300%. Now there is another technology that has been developed based on this technology that we have developed, and that has to do with the time during which at the beginning, when the munition is fired, for example, then it will take most thermal batteries between 50 to almost 200 milliseconds to get fully activated. And during this time, what we do is that we have put a small piezoelectric element underneath the thermal battery, which is compressed during the firing, and during this time, very quickly, within a few microseconds, it provides electrical energy that can be used to power the electronics, usually low power electronics in the munition, for that 50 to 100 millisecond time before the battery comes on. So that way, the munition has power from very, very early on as it exits the barrel. So as I indicated, the objective was to significantly increase thermal battery runtime, which we have. We can show that for most battery sizes that are used in munitions, we can increase the battery runtime by 200-300%, which is extremely important, particularly when the munition is supposed to have longer runtime due to increase in the range of the munition. These thermal batteries can be used in munitions of gun-fired munitions, in various rockets and missiles and bombs. The most important thing in this particular technology is that the manufacturing process is exactly the same as the manufacturing process, the current manufacturing process used for thermal batteries in munitions. The only thing that is changed here is that we are using a heating element that you will see in the next slides that are wrapped around the battery core, so that, and it's initiated at the time of battery initiation, that will increase the thermal heat that the battery has in order to keep the battery core above the operating temperature of the battery, which in most cases are around 350 to 360 degrees C. The technology is very mature. It's at TRL level 6 to 7 minimum, and the manufacturing readiness level is very close to 10, because we are using the same technology that is currently used for the thermal battery manufacturing, and that component, the heating fuse component, is a very simple component, and there is a lot of experience in making delay fuses, and this is really the same technology that is used here in our runtime increasing technology. Therefore, if someone has any battery that requires longer runtime, we are ready to make prototypes to show you how it works so that you can test it. The important thing also is that most thermal batteries, especially smaller ones, are not designed only for providing the required power. They're usually designed mainly to have enough heat mass so that they can last long enough, in other words, to have long enough runtime. So almost all thermal batteries used in munitions, they can provide a lot more power than is really necessary for the munitions. So the only reason they are larger is because of the requirement of runtime, which requires larger heat mass. So by using our technology, you can make the battery smaller, or you can keep the battery, if you need much longer runtime, you can keep the size and just increase the runtime by adding our technology. In here you see, in this slide, you see the two batteries I showed in the previous slides, and the left one is the battery with just the insulation, and the right one shows how our technology is working. So in the right one, as you see, there is a coil around the battery core, which goes around and also spreads over the top and portion of the bottom surface of the battery core. So the way it works is that when the battery, the thermal battery is initiated, in other words, when the battery pyrotechnic is ignited, then the heating fuse also is initiated, and it burns very, very slowly, usually 10 to 20 seconds per inch, and slowly it burns and it provides heat. In this particular case, we have around 2000 degrees C heat temperature of the heating fuse, and we usually put a layer of aluminum, thin aluminum foil around the battery core to spread that heat, and that helps keep the battery core at its operating temperature. The operating temperature usually in these batteries have to be above 350 degrees C in order for the electrolyte of the battery to stay liquid and make the battery and keep the battery active. So as the heating fuse burns, then the aluminum foil that we have around it would spread the heat and keep the battery core warm. In almost all these tests, we have done numerous tests, and we have fabricated several prototypes, and we have fully tested them. And as you see in the X-ray picture, the battery cores, the battery cores are identical, and these two batteries are, the battery core is also part of is already been fielded, is a part of a fielded battery. So the battery is used and is fabricated exactly using the same process that thermal batteries are developed and produced and also tested. So for this reason, the TRL level would be, has been determined to be 6 to 7, and the MRL level should be very close to 10, because all the processes for manufacture has already been developed. The only thing that is really needed is that we can use, and we are trying to get a MANTEC project going to do that, is to develop a way of manufacturing equipment to make these heating coils automatically. Right now, they are made manually one by one, and in order to reduce the cost of it, which is not much, but still, in order to make it more cost effective, we want to we are in the process of getting funding, or trying to get funding to make an equipment that we have designed that would automate, semi-automate the manufacturing process for these tubes. And by the way, our partner we have two partners. One is the one that assembles that manufactures the batteries, and that's Advanced Thermal Batteries in Maryland. And the other one is Hanley Industries, which is located in Alton, Illinois. And they are extremely experienced in making heating fuses or delay fuses for different munitions, for hand grenades and this and that. So they are the ones who helped us develop these heating fuses. And the process, as I said, is exactly the same as any other process that is used for making thermal batteries. Therefore, we are really ready to transition this technology to munitions for almost any application. Current status of the project: we are almost close to the end of the project, and we have really developed the technology is fully developed and tested with numerous prototypes and tested exactly the same way that batteries are tested for munitions. Therefore, the TRL level is very high, it's 7, and the TRL level is even higher, probably close to 10, because we are using exactly the same technology, the same manufacturing process that is currently used for making thermal batteries. And the fuse component, the heating fuse component, is made exactly the same way as delay fuses and so on, and similar devices are used in pyrotechnics for pyrotechnic component. Therefore, there is nothing, there is really no risk involved in this project and in this technology, and we are really ready to make prototypes for testing for any applications that requires thermal battery for their operation, and particularly those that require longer runtime because of or the same size battery if it requires longer runtime, or if you want to reduce the size of the battery by providing the heating fuse on it so that the battery core can stay warm, and therefore the runtime would match the required runtime. In most cases, in almost all situations, especially when the batteries are small, which is the case in most munitions, the main design factor is the heat mass, because the heat mass has to be large enough so that the runtime of the battery would be long enough to match to satisfy the requirements and for the flight requirements. So for that reason, people make the batteries larger so that the heat mass is larger, so that the runtime is long enough. So by using our technology, you can make the battery smaller if you need, and for the same runtime, or you can keep the size and increase the runtime. As I indicated, our technology is used to increase the runtime of battery, and if you need small amount of power right after the firing, before the thermal battery comes on or any other reserve battery comes up, which is usually from 50 to 200 milliseconds after activation. If you need that, then you can use our hybrid design, in which we use a small piezoelectric element to provide power at the beginning while the battery is being activated, so that the power the electric power is around for powering the usually the low power electronics. But the use of our technology would give you the advantages that are indicated here: smaller battery size and significantly longer, especially for significantly longer range munitions, and smaller size if you don't need the runtime. Then you can either you can also reduce the battery size if you do not need longer runtime. And one of the things that a lot of people are trying to do is to replace the liquid reserve batteries with thermal batteries. And in order to do that, one of the issues is the battery runtime. and our technology helps you to replace liquid reserve batteries with thermal batteries if the runtime of the liquid reserve battery was one of the reasons for choosing liquid reserve battery. As I indicated, our technology is really ready for transition. Our TRL level is 6 to 7, MRL level close to 10, and we have fabricated several prototypes and fully tested them using the same methods that under load, same methods that they are used in actual munitions. And also the manufacturing process is exactly the same for all components, for the battery itself and for the heating fuse element that is already used in the thermal batteries, for thermal batteries, and for the heating fuse for delay fuses and similar Partechnic based components. The main thing that the only issue that we are following up now is to make the process of making the heating fuse elements more automated. Right now, we are making them manually, and that's really the only component that requires some development. We have already designed the equipment for it, and it only requires some funding to develop it. If someone wants to, reduce the cost. Right now, the cost of making those heating fuses is not very low. But it's not really high. It just takes half an hour or so of a man hour to manufacture them, and we like to make it automated, so it takes a few seconds in order to do it. And that's really the only thing that the cost reduction task that one might be interested in funding. Otherwise, the technology is ready. If you have any application that requires thermal battery, we are ready, and we can make prototypes for you and for your testing. Thank you. As I indicated, the technology is really ready for transition. TRL level is 6 to 7, and the MRL level is close to 10. And the only thing that only funding that could help we are looking for right now, which is really for cost reduction, and that's MANTEC funding for automating the heating fuse production, and because these days we are making them by manually, and that way, if you automate it, then you could reduce the cost and make it more uniform and reliable. Therefore, that's really the only thing. Otherwise, the technology is ready for transition, and anyone who has a thermal battery, they want to reduce the size of it, or they want to increase its runtime, or if you want to replace liquid reserve battery with longer runtime thermal battery, we are ready to make prototypes for you, and so that you can test. And we have also testing facilities that you can use for the same purpose. My name is Jay Rastakar. I was the one who was describing the technology. The company is OMNITEK'S Partners, and my phone number, my cell phone number is 631-645-3279, and my email address is given here. And we are located in Ronkonkoma, New York, which is in the middle of Long Island. Please feel free to contact us to discuss this technology or its applications. And by the way, we also make the initiation devices for these thermal batteries, and we make them for almost the entire range of munitions, and from a few tens of Gs, all fire tens of Gs, to very high G initiation all fire. And we make them such that, for example, even for a very low G level, let's say a munition that its all fire G level is let's say 20 Gs, and it's no fire for let's say 10 milliseconds or 3 milliseconds, and its no fire is 5,000, 6,000 Gs for even longer time. We can make those inertial igniters for them. And we have a wide range of them, and feel free to call us and ask for initiation devices and safety devices that may appear to be even almost impossible to make. And we have a full range of them, and we are happy to discuss it with you and explain how they work and give you even some of them. We can even give you samples and test results. Our initiation devices are highly reliable. They have been tested to show 99.9% reliability with 95% confidence level. And our technology for the thermal battery increasing the runtime is, as I said, TRL level 6-7 and MRL level very close to 10. And therefore, we are ready to satisfy any requirements in these regards. Thank you for going over our slides, and please contact me if you have any questions or any applications that you may think that we can help in. Thank you.